It's way more efficient. And then that translates into energy efficiency. And you can also store it for extremely long periods of time. So it's these three things that make DNA an attractive storage medium.
I'm sold. Now I just have to ask, where is this DNA coming from? Welcome to Talk Bio to Me, the show where we sit down with the people building the future of biology. I'm your host, Flo Lumsden, founder of Chorus Studios, a podcast production company where we transform complex technologies and breakthrough ideas into human stories that educate, entertain, and inspire. This year, we headed to SynBio Beta, the world's largest conference for synthetic biology. This mini-pod features some of the most fascinating founders.
We make spores that actually eat the insects.
Scientists.
We have carbon-fixing microbes that can essentially eat emissions.
Researchers.
This is going to make DNA into a programmable material that we can use to turn biology into infrastructure.
Investors.
Because it's garbage in, garbage out on AI. And Mother Nature still works in mysterious ways, right?
And AI innovators.
I'm increasingly excited about AI actually making an impact in the lab.
Shaping the future of biotech. From breakthrough therapies to AI that's beginning to design biology, I discovered one of the most exciting technological revolutions of our time. Okay, talk bio to me. Welcome to Talk Bio to Me. We're going to be talking about your company, Biocompute, and learning about it. It was great to meet you last night at the event, and I just thought what you were doing was so wild that I had to bring you on today to learn more about it. So first, give us a brief introduction of your name and what you do.
Yeah, thank you so much for having me. It was also fun hanging out with you last night. Yeah, I'm Anagha. I am the founder of the startup called Biocompute. So we are building storage and compute hardware using biomolecules so that we can make our data infrastructure more space and energy efficient.
So I normally ask people what problem they're trying to solve, but I think in this case, it's pretty straightforward. Like we all know data centers are a big topic of conversation right now, and that's sort of the problem you're trying to solve, right?
Yeah.
How is it that DNA storage is different from usual storage?
Right. So, I mean, the obvious difference is that you're using the molecule DNA to encode data instead of, say, using a disk in case of HDD or like NAND gates in case of an SSD. So-
Say that again?
NAND?
NAND
Yeah.
gate.
Yeah.
What the heck is that?
Okay. It's like a fancy word for like stuff that either traps electrons or doesn't trap electrons. So in all storage devices, you basically just try to create a binary condition where there is something or there isn't something. So in this case, it's like whether an electron is trapped or not. In case of a hard disk, it's more like, is it a north polarity or a south polarity? So you're always trying to create like binary conditions.
Like a 0 and a 1.
Yeah.
Right.
So basically, I mean, you do the same thing with DNA because that's what makes it a storage medium. But just in terms of like capabilities, significantly denser. So we're talking about like 200 petabytes per millimeter cube. And a petabyte is like 100,000 terabytes.
Okay, that's a lot of terabytes.
Yeah.
So it's just way more efficient.
It's way more efficient and like in terms of space. And then that translates into energy efficiency. And you can also store it for extremely long periods of time. So it's these three things that make DNA an attractive storage medium.
I'm sold. Now I just have to ask, where is this DNA coming from? Are we creating it from scratch? Are we taking it from people and animals?
Yeah. So
Maybe you're like, that's a dumb question.
no, I think this is also like a niche enough space for like, all sorts of questions.
Okay.
And if it's any comfort to you, like, so because this is such an interdisciplinary space, if you go to a biologist and start talking about it, they'll be like, hey, I understand DNA, but what is data storage? And you also get the reverse question from like computational folks. So like, yeah, I understand like data storage, but what is DNA?
Right.
So we are sort of like in this very interesting intersection where nobody can claim that they fully understand it.
Okay, that makes me feel a lot better. I feel that better.
Yeah. So your question about where is the DNA coming from? So you can either use synthetic DNA or natural DNA. So many of our competitors, including Atlas and Biomemory, use synthetic DNA, but we are using natural DNA because we believe that's the cheapest raw material that's out there. Plus, you can actually leverage enzymes to program it. So in a way, you're treating DNA like a blank disk and you're writing data into it instead of creating new DNA each time you need to write data.
Right.
So that's our, proposition that, hey, we're going to like bring down the cost of DNA data storage by just not doing new synthesis.
Right.
I would
Because
say.
it seems like that would be a whole extra manufacturing or process of it that you're cutting out.
Yeah. And more than the process, so of course, like synthesis is something that happens at scale. So, for example, like Twist, that's like, one of the sponsors of this conference, their core business is DNA synthesis. But the idea there is that you use synthetic DNA for, say, pharma applications, for R&D applications, and now more so for like a lot of assays to generate data for like AI platforms. And that's like a business of its own. But I just think that's like synthesis is not the pathway that's going to get us to DNA data storage.
Okay. Very cool. I feel like I actually understand. I'm feeling smart. I feel like I'm understanding this better than I did last night. Last night I was like, putting data in DNA? What?
But that's also because you had like a couple of glasses of
I
wine.
did. I was like, okay, now I feel smart. It's in the morning. We're in the morning now. What are some challenges of moving? Do you move data from one type of storage to another? Are there any challenges with that?
Yeah, so it's sort of very similar to how you would move data from like hard disks to SSDs, for instance, that you have to like do a large scale migration exercise. So you would have to do something that's very similar. But in terms of like processes, so our system basically integrates with existing data center infrastructure, which means that you can actually plug it in and, do things with it. So migration is not like the biggest challenge with this. Yeah,
Oh, cool. Is Biocompute your first startup?
it is. Actually, not really. Like, so I used to build a mental health nonprofit before this.
Cool.
Yeah. But that was something I was doing like while I was still in college. So it wasn't my full-time job, but this is my first full-time founder role.
Cool. What are some of your goals for Biocompute in 2026?
Okay, this is exciting. One is basically get our system out of the lab and into the real world. That's like the biggest goal. So we want customers to be able to use it, interact with it, give us feedback so that we can keep building on this and get it to a farm that you can manufacture it at scale. So that's the biggest piece that we are focused on this year. But apart from that, like all the ancillary things that come with enabling this, like fundraising, hiring the right folks, all of that is a part of this. So yeah, but that's the big goal.
Okay, cool. That sounds like a great goal. I hope that you accomplish that. Have there been any like surprising or unexpected lessons you've learned as a founder so far? Maybe about building a team or
I think that's like a lot of stuff. But I try to pick out like the most important ones. I think one is just about so something that I really underestimated when I started was the operational complexity of supply chains. So I just assumed that you could, get everything off the shelf and do things. But the biology supply chain is a mess. And we've had to like really sit down and like negotiate with vendors, identify the right vendors, stick to them, have like, SLAs with them to like do long term stuff. So supply chain constraints is something that is severely underestimated. But I think because we've dealt with so much of that, we've now actually like been doing a lot of our own supply chain. So for example, we work with a lot of CROs to directly source things instead of sourcing them from large companies and their distributors. So
it's a CRO?
It's a contract research organization.
Okay.
So you can basically like just tell them, hey, make this biomolecule for us and give them the recipe and they just like make it in large quantities and give it to you.
Cool.
I mean, that's one of the things that CROs do, but that's what we leverage CROs for.
That's awesome.
Yeah.
Last question. Why did you come to SynBio Beta this year?
So SynBioBeta is like the community of, folks who are looking at synthetic biology and commercialization all in the same, like at the same event. This is not something that typically happens at conferences. So if you go to an academic conference, they're like extremely academic. They're more interested in just talking about like the pure science, the data. And when you go to commercial conferences, it's more like people just trying to sell stuff to you or like just, talking about like consultants talking about how this industry is going to grow. But I think SynBioBeta does a great job of bringing together the scientists and the entrepreneurs and talking about product in a way that makes sense to both of these audiences. So I'm largely here to find my tribe, but more so also just network with potential investors, with potential future hires, just meet other people who are building and learn from them.
Yeah, like-minded, at that intersection of bio and commercialization.
Yeah.
So cool. Thank you so much for talking bio to me today. I can't wait to see how your year goes.
Yeah, thank you so much.
Don't forget to subscribe or follow Talk Bio to Me on Spotify, Apple Podcasts, YouTube today for episodes dropping very soon.